In this video, I'm going to introduce angles. I'm also going to give you the names of components associated with angles like rays. I'm going to talk about units to measure angles, and I'm going to give you some names for types of angles, among other things. All right, so first of all, what is an angle? An angle is an opening between lines or line segments. So let's say that I had two lines that crossed, okay, and this opening right here, this area, we refer to that as an angle. Okay, now there I showed you an angle with two lines, and you can also have two segments that make an angle. Okay, they have to be joined at a point. That point where they join, that dot, that location, that's called the vertex of the angle. Okay, so we have a vertex, and the two segments come together, they intersect at the vertex, and so those line segments then make an angle. Right? Now, ideally, in the ideal situation, not the real world, but an ideal angle, the opening goes out infinitely far. So, in other words, these line segments, these arms, would extend from the vertex and keep going and going. Okay? Just to keep it simple, the ideal angle, we think about these arms, these line segments going off forever, just like we think of lines being straight and going on forever in both directions. Okay? To denote that, we will, because I can't draw an infinitely long line segment, people will often put arrows. When they have arrows, that means that they intended that they would be extended indefinitely in those directions. Okay, so I could do that here for this. And so if I did that, notice that I have let's see, it's not really a line. Each of the arms of the angle is not really a line, because a line is infinite in two directions, right? But it's not really a line segment, because a line segment is just a piece of a line, a finite stick. So this is kind of between both, right? It's infinite for one part, but then on the other side it stops at the vertex. Okay, when you have something like this, something like that you might associate with an arrow, so it starts at one point and then it continues in one direction, this is referred to as a ray. Okay, so in the ideal situation, an angle really is formed from two rays that both start at the vertex point. All right. Now, let's classify different types of angles, now that we know that they're openings formed from rays. All right. So, what if I had, and when I'll talk about angles formed by lines and line segments, and know that again, so we'll call those angles, but in the ideal case, really it should be rays that go off, right, that are infinitely long in one direction. So, okay, so let's say that I had two, let's say that I made a cross. All right, and so the cross creates four angles that are the same size. Okay, the opening is the same size. Here we have angle 1, angle 2, angle 3, and then a fourth angle. All right, going around the circle, and they're all the same size opening. Okay, when you have a situation like that, then these are called right angles. All right, so right angles are formed from from across where it makes 4 equal angles, and each of those is a right angle, so you have 4 right angles. All right. What if I had a ray that went in one direction, and then what if from the vertex I had a ray that went in the exact opposite direction? Okay, so that's making an angle, but the two rays, it looks basically they combine to make a line, right? Okay, now if you have a situation like that, then this angle, this special angle that's, by the way, this angle is the same size as two right angles. It's double the size of a right angle. When you have this situation, this is called a straight angle. Okay, you can think of a straight angle as double the size of a right angle, or you could think of it as made from two rays that form a line. All right, and then in terms of these, we can define other angles. If you have an angle that the opening is smaller than a right angle, that's called an acute angle. If you have an angle that's bigger than a right angle, but the opening is smaller than a straight angle. Okay, so if you meet those criteria, something like this, that is called an obtuse angle. Okay, so obtuse, bigger than a right, smaller than a straight. Okay, now let's talk about how we measure angles. All right, we are going to need a standard sized angle, and we're going to measure different angles by how many of this standard size we can fit within our angle. All right, and the standard size that we're going to use is a degree. Okay, let me go to a new page. Suppose that I had this extreme case. Suppose I had a pizza, and suppose I had 360 people I had to feed. All right, that's a bit extreme, but then suppose I chopped the pizza into 360 equal but very tiny pieces. Okay, so there I've chopped it into what, 8. Okay, and then I could chop each of those in half. I'd get 16 of that size and 32 of that size. So clearly I'd have to keep going. But if I kept doing this and I had 360 equal pieces, I would have something really tiny. Maybe it would look, the pizza slice would be something like this. Okay, when you have that, that's a degree. Okay, and it takes 360 degree angles to make a full circle. Okay, now let's think about how many it takes to make a right and a straight angle. So it takes 360 to go all the way around. A straight angle is half of a circle, so it takes 180 degrees for the straight angle, and then a right angle is half of a straight, so it takes 90 degrees. Okay, so right angle is 90 degrees. Straight angle is 180 of those pizza slices all lined up. That would make something that's the same size. Okay, and then so we would say that an acute angle, it takes less than 90 degrees to make the equivalent size, and then an obtuse angle, we'd say it's between 90 and 180 of those pizza slices. All right, now let me give you the notation we use to describe angles. Let me go to a new page again. So before we can describe an angle, we need to be able to describe the rays that make the angle. So I should probably show you that. Okay, so let me label a few points. Let's call this A, B, and C. Okay, first of all, if you wanted to describe the ray, you have a ray BA, and we put an arrow on top, so that's how you designate that ray. And then we have a ray BC, and those two rays make the angle. Okay, if you wanted to describe line segments, we have the BA line segment and the BC line segment. Okay, you can think of either of those cases making the angle with a vertex at point B. All right, now how do we describe the angle? What you do is you have to list three letters. The three letters, one of them is the middle one is the vertex point, and then the other ones are on each of the rays or line segments. So for here, I could say A, B, and C, and I use a little angle symbol. It looks like just an angle, okay? And so I can call that angle ABC. Now there's no reason you also couldn't call it angle CBA. That follows the rules. Okay? Both of those are perfectly fine. The only thing that you have to remember is make sure that the middle letter is the vertex point, and make sure that the first and last letter are on different rays or line segments. Okay? Now the same way that we talked about something chopping a line segment in half, we called that a bisector, a line segment bisector. You can have a segment, a line segment or a ray that chops an angle in half. Okay, so this right here, we would call that the angle bisector. Okay. By the way, let's name the angles formed on each side of the angle bisector. So let's say that I call this point X. Okay. So I want you to. I'll give you a few seconds to try this now. So I want you to name this angle. I'll put a question mark. Can you give me a name for that angle and this angle? Okay. Where I've drawn the arrows. Okay, so the bisector created two angles, and those angles, one possible name for them, the first one you might call it angle ABX, and the other angle you might call that angle CBX. All right. Now, both of those angles have the same size. All right. The opening is the same. There's another way you could say that. Okay. Now, another term that you might want to know, let's go back to right angles. When we had right angles, I said you had this cross, and then it made four angles that were the same size. One way that we designate right angles is people will put a little box like this. All right, that means you have a right angle there. When you have two line segments, two lines that make right angles like that, we say that the line segments are perpendicular. So perpendicular lines or line segments form right angles where they cross. All right. Now, some other things that we can point out. What about if somebody was talking about the distance of a point from a line? All right. For example, you might say, how far is a certain house from a freeway? Okay. Now, there may be some ambiguity in how you measure that. When you put your ruler, do you measure the distance from that point? Does it matter what angle you use? So you have all these red sticks. You can measure the length of each of those sticks. Which one should we designate as defining the real distance of the point from the green line? And the answer is that what you do is, when we say the distance of a point from a line, you want to only use the point that makes a right angle. Okay, so this blue stick, line segment, I'll put the right angle symbol there. So the length of the blue stick is what we would call the length the distance between that black point and that green line. Okay, and a few more terms. What does it mean to add and subtract angles? Let's go back to this right here where we had the angle bisector. Okay, and when we talk about adding angles, what that means is you line up the pizza slices so that the vertices are on top of each other, and they share one side, and then you end up making a bigger angle. Okay, so for example, for what I have written here, ABX, the one of the ones that was created when that green bisector chopped ABC in half. If I said I wanted to know what it means when I add that to CBX, that would give me a new angle, which is the the same size as ABC. Okay. Now we don't say that to be precise, we say that the measure. So I'll put a little m there. We haven't seen this yet, but if I put a little m in front of the angle symbol, that means I'm asking for how many degrees. So the ABX has a certain number of degrees that fit in there. So the measure of that, the number of degrees plus the number of degrees in CBX, is equal to the number of degrees in ABC. Okay, so that's what it means to add angles. Now you can also invent subtracting angles. So if I took the ABC and I wanted to subtract, so that what that's going to do is it's going to shrink the opening of the angle by the size of the angle that you subtracted. So like if I subtracted CBX, okay, that's going to, what's left over if I shrunk ABC by the size of CBX? Can you see that that's going to give me an angle the size of ABX? Okay, so there's adding and subtracting angles. And by the way, I said that in order to add and subtract angles, I said that they had to share the same vertex, and they had to share a side. Okay, whenever you have angles that satisfy those criteria, they share they have the same vertex and they share a side. I'll put this in the bottom right. That's called adjacent. Okay, so adjacent angles share a side and a vertex. Now notice, as another example of adjacent, I kept drawing a cross when I was talking about right angles, right? And notice that when I draw a perpendicular lines, right, we learned that term also. When I have perpendicular lines, notice that it's creating adjacent right angles. Okay, think about why that is correct. All right. Now, what if I had, now that we learned about adding angles, what if I added two angles, so I lined them up with the same vertex and they shared a side? Okay, and what if when I made the angles to be adjacent, what if that created the sum, what if the sum created a right angle? If the sum creates a right angle, we say that those two angles form a complementary pair. So they're complementary. Okay? Now, another thing that we name, what if I had maybe an obtuse angle and an acute angle? Okay? And so what if this time I put them together and this time they formed a straight angle? Okay? Then we say that they are a supplementary angle pair. Supplementary. Okay? Now notice that two right angles also make a supplementary angle pair because you put them together and you also get a straight angle. All right? And then the last term that I want to impress upon you is, what if you had lines or line segments that made an X? So I'll do this in the bottom left. Okay? If you have two straight lines or line segments and you make an X, the angles that are on opposite sides, so let's call this this angle right here and this angle, those that are on opposite sides, we say that those form a vertical angle pair. Now, vertical doesn't necessarily mean up and down, because there's another vertical angle pair formed from the x there. Okay, the angle from this green with that green arrow and this green arrow pointing to, those also make a vertical angle pair. Okay, but it has to do with crossing lines or line segments, and then on opposite sides. That's how you define vertical angles. All right.